Yeah, good morning. And this is the project 2 for module 4. Um, the We are supposed to download this Excel file. So you click on this to download. So after you download, we have to import it into our Power BI. So I have my Power BI here. So I will click on get data and then Excel workbook. Uh, then I'll look for the file I downloaded. I have already downloaded it, so it's here. So I have MD water services data. So I click on it and I click on open. So after clicking open, you should see something like this. So you should see all the tables in the Excel file. So you have to select all of them so that you can import them. So I select everything here and click on load. But then you can click on transform data first so that you know that everything is in their right order. Let's say all the columns or all the columns contain or they have the right data type. So I've clicked on that. That will take some time. Okay, so that you can look at the data. Okay, here. Um, when I look at infrastructure cost, this is the data. This is how it looks like. All right, infrastructure costs. So I have up to this point. Then we have, but infrastructure cost, we have improvement and unit costs. When it comes to location, you can see column 1, column 2, column 3, and that is not what we want. We want it to take the first row as our heading. So you come to the home tab and here you see use first row as heading. So I click on this so that we use the first row as my header. Then I come to project to check that one too if everything is okay. All right. So here too I check, and here you see that we have record ID, we have percent male, percent female. But this column is just some numbers. So I decided to delete it because it's not doing anything. You would think maybe it identifies each row, but the record ID does that. The record ID doesn't have repetition, so it's for each record. So this one is useless. I can click on it and come to remove columns. So remove column. So, yeah. So I've removed that column. Then I come to the visit table. Visit table, there's nothing here. It's okay, everything is okay. The water source, nothing. I come to water source related crime. That one I have crime ID, identifying everything for me. Yes, we don't have any repetition. So let's remove the column here. So I'll go to remove column here. Great. So you can also check if you have duplicates. We don't have duplicates in the crime ID. So that can serve as our primary key, or maybe the unique ID. Yeah. So let's go to well pollution, and then everything is cool. So we are done. So now we can click on close and apply. Okay, so it has applied the changes for us. So we have all these ones here. Now it says I should go to the model view and see. Let's go there and see. Good. So if you did everything right, you should see something similar to this. All right. So let's try and compare it to what we have here, if everything is okay. Now we have, I think the water source will be our I've forgotten the name, but there's a name for this particular one. Uh, I've forgotten. So this table is the central table in my best explanation. This is the central table. So it is being linked to well pollution. That is one, two, I think one, two, one also. Let me check. So that is our central table is water source. So here we have the water source. Let me put it in the middle here so that I can properly visualize it. Okay. I don't want lines to cross to confuse me, so I've tried to place them. Okay. Okay. So I think this one, the software is trying its best to link them, create the relationship, but then some of them may not be perfect. So we are trying to look at what they have so that we go by it. So let's try and then read ahead if we can correct that. So it says if you do a quick scan of the model, you should notice several one-to-one and one-to-many relationships, along with directional indicators for each of these connections. Have a closer look at visits. Remember from SQL, we use similar table quite often to join tables together because it was a bridging table. Two of our tables are in the model, but they are not currently imported and the relations are not established or the relationship is incorrect. In order to use the data in those tables, we have to fix this first. Let's start with location. The first issue is that none of the column names or headers were imported correctly. So the location issue, we have solved it. In our case, we have solved it already. uh, the columns were not imported correctly. So open up the Power Query editor and fix that. As soon as you do this, location should update its relations automatically. Next up, check out queue composition. You can fix that problem by removing column 1 from the model. It was an identifying column from SANES data that we don't need. So we also looked at this and then resolved it earlier. That is this one. This one was having a queue composition. Yeah, it was having a record ID together with a column in addition and remove that one. So it has been resolved already. Finally, we need to connect water source related crime to the rest of the model. First, remove column 1 from the table. So water source related crime also has column 1, which we did. Water source related crime. So that one too, it has the crime ID as our identifier. So we remove the column 1 from it. Okay. So now here's the challenge. Power BI doesn't recognize that look, loc ID is related to the location ID columns because the name is not exactly the same. But the question is, which table do we connect it to? Let's take the tech way and just try. So we are going to open the relationship manager and link water source related crime to visit using the location ID. So we are going to connect water source related crime to visit. So let's go to relationship. Okay, let me close this. So we have water source related crime here. We are going to link it with visits. So this and that. So we are supposed to go to relationship and do that. All right. So I'll close this and then do it the manual way. So we go to manage relationship and then new relationship and then we go to water source related crime. We'll link to visits, but then we use what? Location ID. So location ID. Now this is going to be should be one to many, I think, because so let's read on. If you try, Power BI warns you that there's many to many relationship. As you may have seen, many to many relationships often cause problems with filtering, so we should avoid this. So that is what is giving us this warning here. Here you see this relationship has cardinality many to many. This should only be used if it's expected or blah 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 blah. So we let's follow their instructions. Maybe there's another thing they will say here. So let's unpack the problem a little. Water source related crime contains crimes over the last 10 years that happened either at or near the water source location ID. More than one crime could have been committed at a specific location. So log ID is not unique. Log ID is not unique in where? In the water source related crime. When you look at the water source related crime, this ID is not unique because uh, this harassment crime can happen in this location and harassment can happen in the same location some other time. So it's the location ID can repeat. All right. Uh-huh. So similarly, visits have multiple visits to some locations. So location ID is not unique either. All right. So the visit also has the same problem. So location ID can repeat in the visits table because the visits, someone can visit this place multiple times, and that is what we are talking about. This is why there is many to many relationship here. Power BI cannot connect location IDs because it cannot figure out which duplicated location ID in visit is linked to location ID in water source related crime. So how do we solve this? We have two options. One is to create a bridging table that will have unique location IDs linking to visits, or in our case, we are lucky because one of our tables already has a unique set of location IDs. So go sniffing around a bit and figure out which table has unique set of location IDs. Okay, and link water source related crime to the data model. So which table do you think will have location IDs, unique ones? I think it will be the location table so that we link it to water related crimes. So let's go there again. So if I choose location, you see location has location unique location ID because we have address, location ID, location type, province name. This keeps records of all the locations in the community. Okay. So we have a unique location ID. This one doesn't repeat because we are just looking at address and the location type, province name, and town name. So it doesn't appear more than two or more than one. So I can select this and link it to that one. Okay. So after doing that, let's do it one to many. Let's start with location here because many to one can give us problems. So let me select location here and come and select water related crime. So this location will link to this so that I'll have one to many, right? Then I click on save, right? So I can close this. Now I have established that relationship with that. Okay. Next up, let's look at the relationships. Many of the relationships in our data model have bi-directional filtering, but most of them are one-to-one relationships, which is perfectly fine. Remember that one-to-many relationships with bi-directional filtering can cause problems, so it is best to start off with as many one-directional filters as possible. And if we run into an issue, we will change it. So let's check if ours is also the same. So if it is 1 to 1, that one is bidirectional like this one. You see that is bidirectional. The arrows shows the two arrows. And then this one is one to many. You see one to many. And so it is only one direction. That one is okay. They said the ones that are 1 to 1, if it is bidirectional, no problem. But if it is one to many and it is bidirectional, you have to be careful so that you like change it to one direction so that at the end of the day, if you need to change it back to bidirectional, you can change it back to bidirectional. So I think we are good to go for now. So it says make sure that all one-to-many relations have single directional filtering enabled. So we have that here. All one-to-many relationship they have. So if I click on this relationship, I see single direction. It's not both. All right. Okay. All of them, all the one-to-many. So this is many to one. So the same thing. The same thing here. But this one is bidirectional. Okay. So let's continue. Okay, now we need to make sure all of the data is loaded as we expected in the table. Numbered columns are loaded as numbers, etc. Spend a couple of minutes going through the tables in the table view tab to make sure the data is correct. So you go through this to see that everything is correct. Crime, crime ID, the data type or whatever is correct. This one, if it is date, so data type is date time. Location ID should be text. That's text. This one to text. When we come to infrastructure costs, this is okay. So you will see that this place looks empty. All right. This place looks empty. But when you scroll down, you see that there are some things here. All right. Okay. So um I want to find a shorter way of removing those empty rows. So I'll select them. Mm, okay. Let's go to transform data on this one. Okay. Infrastructure costs. So remove rows. Remove. Should I say remove duplicates? Remove blank rows. Yeah. Okay. So I've removed all blank rows. Right. That is cool. Yes. I haven't done this before, but this is my first time of doing it. So I've removed all blank rows. So I can now go to close and apply. You should apply. Yes. So it has applied to it. So we are done with infrastructure costs. Let's come to location. Location, we know that location ID, the data type, they are all text. Everything is text. Okay, so we are good to go. Project progress. They are saying the project ID is number, full numbers, source ID, text, Address is a text. All these ones are text, I think. Yeah. Then let's move to queue composition. So the ones that are numbers, you have to be very sure that they are numbers. So this one is saying whole numbers. Percentage, this one, he said it's a decimal. This one is also a decimal. So we know that when we are performing any calculations with them, it will work. And then visit counts is a number. Time in a queue is also a number. Employee ID is a number. All right, that one doesn't have any much effect because if employee ID is a number, you are not going to perform any calculation. All that you are going to do is look for the ID. Okay, so I think that is all for now. Visits. Okay, we have water source here. Water source. Let's look at the number of people saved. It's a whole number. Good. And then let's move to water source related crime. Okay, they should all be text. None of them will be a number. So this one is a date. So make sure that the date is also showing that it's a date. All right. Then what well pollution? Let's check if it's really a date here. Okay, so date. Then here, let's check if it's a number. Good. And then biological is also so. Okay. I think uh, I think that is it for checking if everything is okay. Now we are done. So let's continue. So we have made sure that the data is correct. Because we did a lot of work to clean up the data in SQL, our data looks ready to go. So let's pause a second and unpack the model a bit before we get to visuals. Ideally, we want a fact table. Good. So this is the name I wanted to get in the beginning. So the fact table is the middle one that will link to the dimensions table with details about those facts in various dimension tables. Visit is our fact table because it recorded thousands of inspections of water sources across Majindogo. So I was using which one as our fact table? Let me check. Water source? No. So it should be the visit table, and this is it. Visit table is our fact table. So let me place. I don't know why this one contains a lot of. So let me check. Let me check their model here and see what the water source is linked to well pollution and visit table. Water source is linked to well pollution and visit table. So this is the visit table, and then well pollution is here. So why is it linked to project progress? All right, you let's leave it like that for now. Maybe you'll come across something like that. Okay. Okay, so location has details about where the visit happened. Water source has details about what they found at those locations. Well pollution has more details about some of the sources. Queue composition has data related to who we saw queue when we visited the location. So the queue composition is related to who we saw, whether the person is a female or a male or whatever. But tables like project progress and water source related crime have nothing to do with visits. These are fact tables on their own. So let's check if our project progress and water source related crime are linked to something. Project progress said they are fact table on their own, so it shouldn't be linked to visit table. And then is it water source related crime? Yeah, water source related crime should not be linked to visit. Um, let's continue. But tables like, oh sorry, star schemas in Power BI make filtering and drilling simple, so we always aim for that. But that comes at a cost. All of the data has to be at the same granularity so that the relationships are one to one or one to many. In our case, we have more than one fact table with data describing different things. Water source related crime links crimes from the past 10 years to the source location, which is unrelated to visits. This complex relationship prevents us from making a simple star schema. We could describe our model as multi-star schema. This is common when we connect data from different parts of our business. Connecting data that isn't directly related can help us get deeper insight into our data, but it comes at the cost of efficiency. Why did we just do all of this? Well, now our data model is in good shape to help us visualize data effectively. So let's rebuild the visuals we need. So before we build the visuals, let's go and check the model and make sure that we are on the same page as what they have. Where is the visits? Okay. Okay. Let's let's check if everything is okay. I have okay. So we link the visit to location. That is correct. Water related crime. Water related crime has a location ID, and that one too is linked to location. Alright, so that is also correct. Infrastructure costs doesn't have anything. Infrastructure cost. Before that, let me check if infrastructure costs that we imported, we've deleted something wrongly. Infrastructure cost. Okay, it doesn't contain anything. It's just those improvements and unit costs. That's all. All right, so let's continue. So that will be there just like that. Now we know that these two are linked properly to the visit table. Although this one is not directly linked to the visit table, it is linked to the location ID because this is also a fact table on its own. They said fact table cannot be linked to a fact table. And so let's look at the queue composition. It has record ID. Interesting. The queue composition has a record ID and it is linked to the visit table looking at its record ID. I think that is it. That is the only thing that can link here. And so that is 1 to 1. 1 to 1. If it is 1 to 1, then it means that the number of rows queue composition will have, visit table will also have the same number of rows. Let's check. Queue composition. Queue composition has how many rows? it has 60,146 rows. Let's look at visit, the same number of rows. So we are correct on that. 1 to 1 means every row matches with every row there. And then we have water source. It has a source ID which is linked to source ID here. So the visit table has source IDs linked to water source because this source ID is only one. It's unique. Okay, for each source ID is unique. So it is telling us the water type, the number of people saved. Then it will link to this one. And we also have well pollution. It has a source ID which takes its source ID from here. Apart from that, doesn't have anything that we can link to anything. So this source ID will match with the source ID. I think this one is well pollution for all wells and it matches 1 to 1 bi-directional. Okay. Although they are 1 to 1, but they will not have the same number of rows because well pollution, well water, we have well water, we have tap in home, tap in home broken, we have river, they all form part of the water source. So well pollution is a part of it. So they can't be the same. Let's check well pollution. When you come to the table view, well pollution has 17,000 rows, 17,000 plus. And then water source has 39,650. So they cannot be the same. All right, so I think basically that is it. I think that is it. That is it. But theirs is, let's check if their infrastructure cost links to project progress. And I'm wondering which part. I think it will be the improvement. Improvement. I think improvement that will link it. So let's do that quickly. Infrastructure costs here. So let's do new relationship, one to many. So infrastructure cost will be the one to many, which uh, is it a visit table? No. Is it a visit table or what? Project progress, sorry. Project progress. So project progress. Right. So it links to the project progress. One to many. Right. So I save that one. All right. So I close this and it is linked. Right. Good. Let me bring it to the other side. All right. Okay. Then let me check again which one we haven't. So project progress is linked to water source 1 to 1. Project progress is linked to water source as 1 to 1. So this is our project progress and is linked to water source. So that is 1 to 1. This relationship is 1 to 1. And then where pollution and water source are linked as 1 to 1. Well pollution and water source are linked as 1 to 1. Well pollution is here and water source is here. So they are 1 to 1. Good. And then we have visits and water source. One to many. Visits and this is water source and this is visits. One to many. Great. And then we have visits and queue composition. 1 to 1. Visits and queue composition 1 to 1. Visits. Where is my queue composition? 1 to 1. So this and that. This is their relationship. Then we have queue composition and water source related crime. Q composition and water source related crime. Q composition. This is Q composition. And where is water source related crime? This one. Okay. So they are linked by what? So Q composition and water source related crime. They said we should remove the column one. So if you remove the column one, this cannot exist. So I think we are good to go. If there's any changes or when we start the visualization we see some problems, maybe we can rectify that. But as far as I know, that this one is the model he got after importing. So this one I think they haven't really done so much work on the model. So let's continue. All right. So here, why did we just do all of this? Well, now our data is in good shape to help us visualize data effectively in Power BI. So let's rebuild the visuals. So create a national page and add the following visuals. So we are going to create a national page. So you create the national page by going to report view, renaming this to, we rename this to national page. When you want to rename, you can double click. So national. You can double click on this and it will rename, it will edit or it will bring out the cursor for you to rename it. So that is the national page we have created. Map of provinces in Majindogo. So these are the things we are going to do. These are the things we are going to do. And so it says, remember to set the appropriate filter for visit count. This thing, when we're doing it in a workbench, remember visit count. Okay. I'll explain in due time. And choose provinces and towns from location. Try to use town from project progress to see what happens. Also remember that rural is a town in our dataset. So for number 3, we need to remove the rural data. That is number 3. When we reach here, remove rural because rural is a town name. It is not one of the, should I say, the type of town or something, that it is either urban or rural. That one too is there, but this one too is a town. So we will try and then do what they have done here. Um, okay, I think this one we have done the map before, so we can import the map and get for the first one, that is a map of provinces in Majindogo. So let's first of all import the map. Um, so let's click on shape map. Good. And move to this place. No, not that place. I think we have to get the location first. Provinces. So what are we getting? We are looking for map of provinces in Majinogo. Right. provinces in Majindogo. So if I have province name, I can put in province in the legend or color saturation. Sorry, I think that one is not working. We should work in the legend. Let's go and move in the map from. So we go to this one, the formats, visuals. So we look at map settings. Sorry, oh, it's not giving me that. Provinces in Majindogo. Okay, so let's put in town names. So let me put in town name in the legend or in the saturation. Yeah, so we are counting the number of towns. Okay, let me go there and see if it's still working. Hold on. Province name. Town name. I'm wondering why this thing is not coming for me to add map. Oh, sorry. I'm supposed to choose custom map. Sorry. Yeah. And then select the map for provinces. You should have that map by now. And then I think that is it. So when I click on the map, I will see the changes. All right, great. Okay, so maybe I can add the province name to the legend to color it. Right. Okay. And then you can also edit this by going to, I want to remove the legend because I don't want it. So I come to legend, put it up. And then I can change the title to maybe map of provinces in Majindogo. Sorry, I'm typing map of. Why am I typing wrongly? Map of provinces in Majindogo. Okay, so I can bold it. I can underline, do a whole lot of things with it. I can center it and all that. But I want it this way. All right. The next one is a pie or do not chart of the population split between urban and rural. So we are going to do a pie between urban and rural. So it means urban and rural will be the legend. That is the location type. Urban and rural can be found in the location type. And then the number of people saved for those areas. So when we come here, make sure that you don't select the map. You select an empty space, and then you go and click on pie. Then we add urban and rural. That is location type. Location type here. The location type will be at the legend, and then the number of people saved. The number of people saved can be found in I think water source also. Yes, so water source. So the number of people saved will be in water source. It's not supposed to be here, it's supposed to be in the values column. The values column. Um, but then number of people saved, the source ID. Why are we getting equal number of people saved? So when we go to our table, water source, number of people saved. Look at this. Well, okay, so here we'll have the source ID with the number of people saved here. I think this one doesn't contain repetition. Water source doesn't contain repetition. Yes, water source doesn't contain repetition. Now let's look at something here. Let me see. Remember to set appropriate filter for visit count and choose provinces and towns from location. Try to use town from project to progress to see what happens. Also remember that rural is a town in our dataset. So alright. So I think we are still on track. We have to look at this. So we have the location type. Um, this is the number of people saved. It is counting this. If I put this one here, it's count of number of people saved. This is what it is doing. It is counting this. So it counts this as 1, 2, 3 in that order. But we don't want that. We want to sum for each province or for each location type. So let me click here and go to sum and see if something will happen. Good. So sum is still dividing it into two equal parts. Let me see if there's something I have to do here. Okay. So I sum it. So you see that we have tried and tried and tried with location type and then the sum. We know that we have done the right thing, but then it is still counting as if it has counted the total population 28 million and divided them into two. So rural it will count all the people, sum them, then urban to the same. So you see that they said here that we should make sure that what we filter with what visit count. Now the reason why the visit count is affecting this, you think that oh location type is in a location. There's nothing like visit count there, so it doesn't affect it. And then water source too doesn't have visit count. But let's go and check location linking water source. So when we come to the model view, we have location here. This is location. But location is not linked directly to water source. This is water source. Location is rather linked to visit table before water source. So it is it is like in our workbench, you are joining this table to this table, but it should join this in addition. But this one is linking this to this through the location ID. And so it will copy, it will read all the people in the visits. It will count all the, should I say, the visits, the location that has been visited even multiple times. So we have to limit it so that it will not double count them. That is why we are having 28 million for both sides. It is duplicating values. And so we have to remove the visit, we have to use the visit count to limit it because this table, we should say, is a bridge between the location and the water source. So it is affecting it in that way. So let's go and then put in the visits, that is visit count here. Put it in the filter. Please don't put it on filters on this page, but what? Filters on this visual. So I put it here. And then I'm looking for visit count. So I'm looking for visit count equal to 1. Visit count that is 1, or we should say 1, yeah. But then if we look at these ones, we have less than and equal to, greater than equal to is. So we can say is 1. Then we apply the filter. So I think that one is not working. Let's use a different approach. Instead of is, we say is less than or equal to 1. Apply that filter and see. Still not working. Okay, so since we are still having the same problem, let's just leave it. I think there's an instruction for that, so let's leave it for now. All right, so the next one is this one. So we are going to have a tree map of total number of people per source type. So a tree map of total number of people per source type. So have let me get that again. Total number of people per source type. So each source will have a total number of people. So let's choose. So make sure that you haven't selected any of this. Then you click on tree map. Let me bring the tree map somewhere here and expand it a little bit. Total number of people per source type. So source type will be the water source ID, right? So source ID, let me select it and see where to place it. Source type. So it should be this one rather. Type of water source. Great. And total number of people for that source type will be the number of people served. I think this one. So one should be at the category. Category should be the source type, and then this should be in the details. Number of people will be in the details, so we sum them. Right, so type of water source is in the category, so that it will categorize them in the various types of water source, that is shared tap and all that. So we have categorized them. Then the values will contain the total for each type. So when we hover over it, you see that sum of people saved is 11 million, whatever. Then this one. So this one you can use your workbench to check. You can use your workbench to check. So you select. It will be select sum of type of water source, sum of type of water source. No, sorry, sum of number of people saved from water source table, where type of water source, or we can just do select sum. Sorry, it's not sum. I'm just getting myself confused. It will rather be, let me open it. It will rather be partition. We'll use partition for that. Maybe open and practicalize it and see. So this is how I try to check if mine is correct. All right. Okay. Okay. Oh, why am I denied access? Okay. Okay. So here we will do select. So it is select sum of which one, type, or number of people saved. So number of people saved is in the water source table. So number of people saved. Okay. Over partition by, so we partition by type of water source. Sorry, type of water source. Water source. All right. From the water source table. Water source. But this one will get the sum for all of them. So we align it with type of water source. Type of water source. Let's use the MD water services. Good. Let's run this and see. Oh my goodness. So what we are going to do is that we will not list each time we have a sum, then we know. So let's use group by type of water source. Okay. Am I correct? Is that correct? It's not saying anything. If that's not working, then let's use distinct. So I could have done the sum of this and used group by. I think this one should also work. Why is it not working? All right, so this one should work. Yeah, right. The previous one, let me check if that one too was working. Okay, previous one wasn't working because we have already partitioned it here, so I think it is conflicting. When you use group by, we will remove this so that you can sum it in group by type of water source. All right. So you see, tap in home, we have about 4678880. When we check tap in, is it home? Yeah. So you see the value it is showing. Tap in home. Share tab is 11945272. So when you come here, it is still the same thing here. So you see that everything is intact. We are summing them based on the type of water source. So I think this map looks good. We can change the title and all that. So I think the title is still the same here. So let's leave it like that. All right. So the next one is, and please remember that the tree map, they said we should remove something here, rural, or it's not the tree map. So for 3, we need to remove the rural data sets. So let me check. So we come to is it water source? No. Rural, we are removing. So let me filter by location, town name. Is it town name? Good. So I will select everything except rural. Rural is somewhere here. Yes, except rural. I think this one is not doing anything so significant. I don't know whether that place was a mistake because it affected the other one rather. I think this one rather. But no problem. Let's continue. It's still giving me the same answers. Okay. All right. No problem. It says also remember that rural is a town in our data set. So for 3, we need to remove the rural. Okay, that is for 3. I think one of them it was for the whole data set. Okay. Okay, so let's continue to column chart showing the total number of each source of water source for every town. Column charts showing the total number of each source for. So select an empty space for each, the total number of each source of water type. So we are counting each source of water type. So the water type, if it is well, we are counting the number of wells for each source. We are counting the number of wells for well. Then we count the number of tapping hole like that for each town. Okay. So it means that we will have a count for one of them. That is for counting each source. So I'll look at which one for each town. So let me choose column chart. Where is it? Is it stacked? Okay. So we are going to count each source, and put it here. So that I count each source for each town. But then this doesn't make sense. It means it is counting each source in the water source area. And water source area doesn't contain the number of okay. Okay, so water source it still contains the type of water source. Yeah. So you should be able to count that for us. Town name. So each town we count for the water source, number of water sources. Yeah, so I think that is what was expected of us. I think that is a count of water source right there. Yeah, this is it. All right, but then our chart still doesn't look real. This one, there's something wrong with it. So let's continue. We will rectify all of them. Now it says we should also do the last one. I think we are done with 4. The last one, column chart that counts the different sources by type. The different sources by type. So we are looking at the different sources. So click on an empty space, column charts. Let me choose this one. There's another column chart here. Stacked bar charts. No. Let me put this one here. Good. And they are saying each source type of water source and the number of that. Okay. Let me check again. The column chart that counts the different sources by type. So I'll put the different sources it counts, then by type I put the type here, right? Yeah, I think that is it. Let me choose this. Okay. Yeah, so the different sources by type. So this is the type. It will count each type in that table. So if it is well, it will count 1, another well 2, another well. If it is tapping home 1, 2, so it will count all of them. Then in the x-axis we have listed them well. Then the total it will show. This one it will count the total for you. So all that will be showing up. I think so. That is it. So now let's come and rectify this and that. This pie chart, and then I think this one is count of water source and town name, the one with the town name and the water sources. Okay, so that one is here. That one is the one that we were trying to rectify. So let me use this one. And extend it downwards. Okay, so now let's come and then do the correction. So here it says, now I know you are yelling. My water source visual doesn't look like yours. I know this is a problem with one of our filters. The location and source tables are linked by lines, but the arrow between water source and visits points toward visits. So let's check. Water source and visits point towards visits. So water source and visits. So this and that, this arrow points towards visits. So that is why we are having problems with our work. That means the filter can only work in that direction. When we create the visual that has type of water source as the values, and we want to split up that data per province, the filter has to come from location, where province name is, to visits, which the arrow allows, but then from visit to water source, the filter cannot be applied. So it means that when we are coming from location to visit, the arrow allows us to point from location to visit, but not the vice versa. That is visit to, I think visit to water source. So when you check our data model, location to visit works. So location, then we move to visit. But then from visit to water source becomes a problem. It is rather water source to visit. So that is where the problem lies. That is where the problem, because we are linking this location and the water source. We are trying to do something here and here. So it should be like from here to here, then we pick from here, then we come here. All right. But then when we pick from here to here, we cannot come to this one because this one picks from here rather to the other side. Okay. So it means that there's something that must be done. So the fix, we allow filters to pass in both directions. Set the directionality on the visit water source relationship to bidirectional and it should now work. So let's go and change it to bidirectional. That is this one. So I'll click on it. I think I'll right click and go to properties. Good. And then here I'll choose both. So I'll choose both and click on this. Apply security filter in both directions. So save. Great. So now let's go and check it if it's working. So you see our pie chart is working perfectly now. So when you check the pie chart, it shows exactly what they have. 18 million, 10 million. When you put them together, you should add up to 28 million, right? Because the urban and then the rural people, when you add them. And then here we have this. This one is the one with the, so here they said we should do what? Column chart showing the total number of each source of water type for every town. So each source of water type for every town. So these are the towns. Then we are looking at the number of taps in that area, the number of well. So it means this is not the right graph. So we have to add a legend. That is the the type of water source to the legend. I think let me choose this one. Is it this one? Good. So I chose this one, the stacked bar chart. So you see that it will show river, the amount of rivers in that area, the count of number of tapping. So I put that one in legend so that it will show that, and then the type of water source is here. So that one is in the legend so that it will count for us and show it in the graph. And then the town name is just below it. But remember, they told us to remove rural. So we come to town name here in the filters area, and then we select everything but rural. So select all, then go and look for rural and remove rural. So our data looks like this. Okay. So we can edit the title here, everything can edit and make everything nice. So that is by going here in the y-axis. When you click on the arrow in the y-axis, we can change the title in the y-axis. We can remove it like this. So in the y-axis, I think there's a name there, town name, but I don't need town name. I can remove it because the names are there, so we can clearly see. And I can also make sure that the legend is, so let me see if I can do something about the legend. So legend is here. I click on the arrow, then where it is showing I can't see it clearly. I can bring it to this end, that is this right end. So top right start. All right, good, so that you see the legend here clearly. Then I can read it from here, or I can just bring it below it. So let me see if below bottom bottom left or bottom whatever. So I can place it here. But this thing is worrying us, the type of water source. I can remove that one. So that is under legend. Under legend, that is the title. So I'll remove it so that everything will show clearly here. So I have all the 5 water sources here. And then this count of water type is for the x-axis. I can see number of water sources, something like that. So I can come here. Oh, where is it? That is the x-axis. X-axis, that is the title where the auto is. So I can just see number of water sources. Good. So it has shown there. I can bold it, I can italize it, whatever I want to do. So when you want to do anything to the x, anything about the x-axis should be under x-axis, and the y-axis should be here under legend. So you should know what each of the visuals here represent. This is the legend. This is the title for the x-axis. These are the values for the y-axis. You can equally let them go away, but then we need it in this visual because how will you know that this is for this particular town? And also the title for the whole thing, that will be under general. So title, I can remove it, I can let it come. And I have some properties here, so you can explore all of them. But then I've been able to achieve what we were told to do here. So that is what is here. So we have fixed everything nicely. And some of the things here, you see that This one is 36%, 64%. It has been rounded. So you can also do that. Mine is showing mine is showing in two decimal places. So this is what. So I come and click on this visual. This is our values. So I go to visual uh, here, and then general. Um, Data formats. I think no, not this one. Details labels. Good. I think here is it. So I'll go to values, and then the values, I have value decimal places. So I put it to one decimal place, and you see the, let me put it to 0. Okay, so this one is for the value itself. Okay, so I'll put it to 0. I want the percentage. So percentage decimal. I put that one to also 0. Good. So it's easy to 4% and that. So that one has been affected. Okay. And then here we are talking about type of water source and type of water source. Okay. I think that one is okay. Let me check. We have 10.9. You see, here is 10.9, 4.3. They don't match with ours. Ours is, so let's make the values visible. So I select this visual. So this should be, some of them you have to go through it before you'll be able to identify where those things are. Okay. Oh, data labels, yes. It should be a data label. So when I switch it on, yes, this is what is happening. Data labels, yeah. Good. So that is under visual. So data labels, ours is not working, and let's rectify that. So what is happening here is that we dragged in count of type of water source. So water source, let's check our water source table. So this is the water source table, discounting the type of water source. But then we are supposed to get water source. So here it says column chart that counts the different sources. No, not this one. It's the last one. Column chart that counts the different sources by type. So the different sources by type. Different sources by type. I want to understand this. Okay. Let me arrange my visuals well so that you're not. sources by type. Okay. Um, by type. That is what I'm looking at. Okay, so here, um, let's try and remove the rural from this and see. Where will we get? Okay, so let's add down to the filters table. Select everything and remove rural and see. Okay, that doesn't work. Okay, let's do that for this one. I think this one, let me check. Let's check. So this one, it's the highest is around, it's less, it's more than 1,005. So that's 1.1,005, yeah. So it will be 1K plus. So we have this one showing 1K and over 1K. I think, I don't know whether it's the same 1,005. Yeah, so when you come in, check when you add all these, I don't know. Um, we have already done that, right? We have already removed rural because when we add, yeah, this is how it looks like. So I think we have already done that. Um, okay, so it is when you extend that you will see that shortcuts. Alright, so I think that one is cool. So let's look at this one and work on it. So what is happening here is I have intentionally filtered the town name here for only rural, and when I did that, it worked for what they have. It's matched. So 2.4K for river. We have tap in home broken 2.9K, tap in home 3.2K, share tap 4.3K, and well is 10.9. So I can see that that one matches, and I don't know why they choose only the rural, but this graph is for only rural. So in case you are doing the MCQ and then they ask you questions which is different, or let's say that consists of all the towns, then it shouldn't be this, it should be the one we did. So that will be selecting everything. So this one, okay, when I select everything, okay, all right, or I remove the filter. So but so this one is for only rural, yeah. So I think so far so good. Now we are told to create another page and call it queues and copy the map to this page. So you create another page and call it queues. So I'll call this queues. Right. And we are told The visuals we want to include here are the ones related to queue times. If you try one, you are going to run into a problem. In the table we used last time, I calculated the hour of the day and day of the week for you. But now we have a timestamp. If you use that in the queue time for days of the week, it gives us the option to look at the data per year, month, and day. But we need something different. So let me first of all get the map inside here. So I'll copy the map, paste it. Right. Then it says that when if we try to use the timestamp, is it day of the week? So if you use the time, I think this one, yes, when you try to use it, it gives you these ones, okay, year, quarter, month, right? So that is what they are talking about. It won't really work. So let's look at what they will tell us. Head back to the data model. We need to extract some information into new columns. I know you've never done this before, but I'll show you how to do it. Open Power Query Editor and select the visit table. Select the time of record column and select the add column tab on the ribbon at the top. Then on the date drop down menu, navigate to day and select name of day. That should create a new column called day name. Rename it to match our naming format. So let's do what they are saying. Let me delete this. And we go to the data model. So let's go to transform data. You go to the Power Query. Then we select visits. So we are going to look for visits. Let me remove this. So the visit table. They said time of record. We select it. And then add column here. Add column, and we move to dates. Click on the arrow, day, the name of day. So we click on it, it will add a column. So it has added it here, so we can just label this as day name. So we follow their format, small letters, day name, right? Good. So that is what we have done, right? This is the menu you should look out for. So they've shown you the menu here, and we just did that. Select the time of record column again and create new column that extracts the hour. So this time around, we are going to extract hour. So we go to the same thing. So here in the Power Query, we go to time of record, add column here, and then come to the time, go to hour, we select hour. Great. So hour of day. So we name it hour of the day. So now close and apply and head back to the visual. So we close and apply. So I go to my Power Query. In the home tab, I go to close and apply. So everything has been applied successfully. You should see two new columns under visits in the data pane. So When we go to the data pane, that is here, then we look for visit. You see that we have two columns, that is day name and then hour of day. So that is it. Now let's add these plots to queues page. So all these things will be added to the queues page. So this is what we will get at the end of the day. So let's start. Average queue time per hour of the day as a line plot. So average queue time per hour of the day. So we come to the queues page. Make sure that you haven't selected this. Then we choose line charts. It says average queue times per hour. Is it average queue time per hour of the day? So per hour of the day, we are looking at the average queue times. So this one, okay. So hour of the day is here. So we bring that one to the x-axis, and then I think the day will come. No, this one doesn't work. Should it be town? No. So average queue time per hour of the. Okay, so let's use day name for our legend. Let's see. Is it working? The secondary. No, this is not. Okay, so you said average queue time per hour. So I made a mistake. So average queue time. So we have queue time here. We want the average. So we select average per hour of the day. So I can add day name to day name to the legend. I don't know if that is what they got somewhere. Yeah, this is it. Yeah, queue time and then hour of the day. Yes, so that is exactly what I've done here. So I have the legend here. I can bring it to the bottom, or I can let it be, or to the side. So the legend, where is it? Oh, I have. Okay, so to the top left start, or top right start. Good. I think this one is okay. Now let me remove the legend title. Okay, so legend title. Okay. All right. I think this one is cool. Okay. Now let's move to the next one. Average queue time for each day. So for each day, we find the average queue time. So make sure that you have an empty page. Average queue time for each page, each each day. So average queue time for each day. So that one, I think let's choose it. Make sure that you have not selected any of them. So average queue time. So this is the queue time for each day. So it selected a bar chart for us. Um, for each day, so you should have something like this. Queue time for each day. Let's go and then activate the data labels and see. Okay. So average queue time for each day, but ours is showing some. So we'll go to average. Good. Then we move to the format. In the data labels, we look at the value. Then value in decimal place is 2, 0. Good. And then I think that is it for this one. Okay. Q times per D. Okay, so it's not matching. Average Q times per D. Now let's look at this. We are talking about visit table, so make sure that the visit count is catered for. So visit count, we look at where the visit count is 1. Great. Let me see if this one is 1. So 1 is okay. Visit count is 1, but I'm getting a different value for this. So average user. If I do 1, because some of them the queue time may change. The same place, the visit count. The visit counts may, yeah, the visit count may increase, but then the queue time may change, so it will affect the average. So let's remove that. And okay, so this is showing Saturday average of time in queue on Saturday. Let's try and then put in the day name in the legend. Okay, it gives us the same answer. Okay, day name here. Okay, so 155. So these are higher values. If they are higher values, then what are we doing wrong? 246 matches the one at the end Sunday 82. Oh, okay. Monday 155. It doesn't match. And Friday 137 doesn't match. So what could be the problem? Let's see. So let's read through and then see, maybe we can do some correction. Now let's interact with it as decision maker. So I think these ones are for finished ones. So unless we still concentrate on it and try to figure out what we did wrong. Okay. Okay, so let's check our instructions again. It says the last part, it says make sure to include only shared tabs in all visualizations on your queue page. So it means what we have done is correct, just that we included everything, not only shared tabs. So let's go and look at our water source, type of water source. I'll add it to the filters page and select only share tabs. Right, I think this is correct. Let me give it a colorful thing. So I'll add it to the legends column. Then let me choose this one. Oh no, not this one. Oh. No. So this one is okay. I think the column chart, yeah, it makes it more nicer. So select column chart and put day name in the legends field. Good. So this is okay. I can remove this the legend at the top here from so yeah, this is okay. I can remove the one here. I can remove this because I have values on it already, so I can remove this, the y-axis. So y-axis, the values should go off. Title is on. Can put something there. Let's leave it like that. Okay, so far so good. Third one, average queue composition. So we do average queue composition. Let me shrink this a little. Average queue composition. So where is it? Queue composition. Yes. So I'll select the three, the composition, and the gender. So they are saying the average. So I'll look at the averages for all of them. Average Q composition for water sources, right? Maybe, maybe for water sources. Um, Q composition. Okay, so this one is, let's choose this one. Let's remove this. Okay. Um, let me remove the legend. Okay. So they are displaying either male or female or child. So let's go and change the names here. Here is male. Where is it? Male, because it is average for male. So male. So we type in male. Then this is for child. This is for child. So I write child. And this is for female. 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 Okay. So I'll go here and change, I think, the details, values here. No. Okay, so it should be here. Label contents. So here we are showing data value and the percentage of total. But we want category and percentage. Yes. So here, right. Then the percentage to, let's change the decimal places to 0. I think that is what we have here. 66%, 24%, and 10%. Okay. Okay. So this one, the filter for only shared tabs must come here for filters on this page. So for filters on this page, so let me remove this and do for filters on this page. So type of water source for filters on this page, then share tab so that I will not forget. Right, good. So this is for filters on this page, not for a particular. So filters on this page, so it will affect everything on this page. So that is for this particular one, Q composition. You can also label the title as well. Then here, I think we are done with this, and that. It's left with this and this. I think this ones we are done. We are done with 4 of them. Yeah, 4 of them. So we are left with the last one, which is total time spent and the country, or the province. Total time queued per province. So total time queued per province. Let me click outside. Total time queued per province. So time queued, I'll select. Then I'll go for province. So let me minimize this so that I can see well. I think this is what we have, right? Yeah, Hawassa and all that. We have, yes. So theirs is colored, so you can color ours too by putting in the province name in the legend so that you'll see those colors. Let's choose this one rather. Sorry, let me delete. Select it and choose this. This makes it more nicer. Province name here to the legend. Then I'll remove the legend. Okay, I've not selected it, so remove the legend. Good. I think this is okay. So we are done with that one too. Nice. So you can label the y-axis well and then the title. Let's move on. So we move on to these ones are telling you what is there and then trying to explain certain things. So you can read them and then try your hands on them as to what you have created. You look at it and then you practice. They will tell you to click on one of them to see how it changes and all that. But because of my time, I want to skip that and go to the next page. So you try it after you are done with what we have done here. If you are done with this, you can read that one and then practice to see how they work together. If yours doesn't work, it means that you haven't done something right. Or maybe if you follow everything strictly, then maybe I didn't do something correct. So you look at it keenly to correct them. So next page, pollution data. So we look at the next page, pollution data. So we add something called pollution data. Pollution data. Right. Now copy over the map again. So we will copy the map to the pollution data. So I'll copy this map. Sorry. I'll copy over this map, bring it to this page. Good. So, and edit the map by adding the count of pollution result to the color saturation. Count of pollution result to the color saturation. So come to the visualization, select the map, saturation, count of pollution. So the result of pollution, where is it? Here. So this is the result. I add it to the saturation column. So count. So it's a count of that. Good. Now add a composition chart that shows the number of results by result. Add a composition chart that shows the number of results by result. Clean, chemically contaminated or biologically contaminated. So we are going to add a composition chart that shows the result for this. So composition chart will be a pie chart. So we add results and then counts. So we count the number of contamination, clean, chemically, whatever. I think that should be it. So 41%, 31%, 28%. I think Yeah, so that is it. Then you should have something like this. So you can adjust the result to get to one decimal place. Yeah, like what they have here. This is 4.9k for this one. Then we have 7.1k and 5.4. Yeah, so they approximated these ones, and then that is it. So I think this one we didn't take so much time. Now the map is actually useful. If you select clean, we can see that most provinces look bad green or whatever. So here they are telling you when you select clean is in the blue. So you should see some changes here. So let me click on it and remove the legend. Okay, so clean. So you see these ones are deep. So 4,951 and 4,774, 3, and this is the lowest. So the ones with the deep blue will show that that is the provinces with the clean water. Okay, so this province that is Kilmani, they have more of clean water than sorry, they have clean water like Akachi. So Akachi also have more clean water, but the light blue follows suit, so it colors in that manner. So when I come to contaminated, so these are contamination. So they also have contaminated water, and that is high than Hawassa and the Amanzi and Akachi together. So when you click on this, you have Kermani still contaminated, and that is biological. So um, oh, okay. So the first one clean is just one Akachi rather before Kermani. Sorry, I didn't look at that. So this one is the clean, and that is for Akachi. And this one's Kilmani follows with the clean. Then this one before I think this and that. So this one is 196502. Yeah. So this first, second, third, fourth, and fifth. So I think that is it. So now you can understand. Okay. So you say if we select biological contaminated wells, we can see that Akati is not too bad green. Theirs is green, but ours is blue. But if we select chemically contaminated, we can see bright red or whatever. So I have explained that one. Just a reminder again, Sana pulled data from Majidogo's crime database that were recorded at the locations where water sources are or where victims reported they were traveling to or from. Water sources, sorry. Just a reminder again, Sana pulled data from Majidogo's crime database that were recorded at the locations where water sources are or where victims reported they were traveling to or from water sources when the crimes occurred. You may wonder, how does this relate to water access? Well, imagine you are collecting water from a shared source at night. If you do not feel safe, will you go? This is the grim reality faced by many people in Majindogo and Africa in general. Women and children are often victims at these places, especially in the mornings and at night. So we should check to see if the data in Majidogo also tells the same story. Okay, but before I move on, let me save this. So you should also save it. So I will save it as Let me save it in my downloads. I'll save it as project 2, module 4. So I saved it. Right. Let's continue. So create a new page for crime related data. So we are creating a new page for crime related data. So I write crime related, So, oh, and pause a second to see if you have named all of your pages so far. And so far we have been doing that. Great. Create visuals that will show the following. So we are going to create visuals that will show. So it won't take long, we will finish. I think this is the last part. Plot the different crime types to show the gender disparity that women face. Try to identify the crimes that are affecting women in margin level. Plot the total number of crimes affecting men, women, blah 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 blah. So I think after that we'll get this. So let's take them one by one. You plot the different crime types to show the gender disparity that women face. So different crime types. So okay, let me check if they asked us to import the map again. Okay, so it means we have to import the map again, because since the map is here, we have to also import it. So let's paste the map here. Great. I've already copied it, so mine will just paste. And then they want us to show the gender disparity between the crime types. So where are the crimes? That is water resource crime related. So this is the crime type. Then victim gender. So we have gender here. Let's see if we can use this to show all this. Okay, with crime type should be in the legend. The victim should be account. Right. Crime type. No. We want the visualization that fits. Harassment. No, we want to relate it to gender. So crime type. So this is the crime type. Good. And then the gender. So the gender for the various crime types. Now let's add the gender to the legend. Good. So the females are the ones in the middle, and the ones at the bottom are the children, then the top ones are the males. Right. So let's see if we got similar graph here. So that is gender disparity of crimes. Okay, I think they use the pie chart as we used in the beginning. So let's also use pie charts. So let's put in legend the victim gender. Right. So female. Okay, I think this one is okay. We have represented it in a pie chart, so by gender. So you can manipulate this to look nicer, these values. So that is the gender disparity of crimes. Let's try and then label it. Gender disparity. So I can do general, then I type in gender gender disparity of crimes. Right. Then let's move to the next one. Plot the total number of crimes affecting men, women, and children. These are crimes related to people collecting water. What are the patterns you notice? So the total number of crimes related to men, women, and children. I think that one will now take this. So crime type, the count of gender should be here. Good. And then I'll use crime type in this case. No, let me use gender. So let me use gender in the legend. Good. So I'll have this. And when you check, that is the second one. Gender disparity related to water collectors. So harassment, theft, all these ones. Count of crime type. So we have the same thing, count of. Great. So it is count of crime type, not count of victim gender. Let me put this one there. Okay. So count of crime type rather. So harassment, then it will count total harassment for this gender, then this gender, and then respectively. Okay, so that is for this particular one. I think the highest was above 20k. The highest was above 20k. So let's check if ours is also, yeah. And then you see that their gender female is in the middle, and that is the highest. Harassment is the highest, and the lowest is vandalization, I think. Vandalism, yes, I think that is the lowest so far for the females. Vandalism. Then let's move to the next one. I think we are done with one, two, three. So let's with the other three. Plot the number of crimes for time of day and create another visual that shows the number of. So let's plot crimes for time of day. So crime type, then time of incidents. But then we don't have time of day. I think they wrote something here. You will have to make hour of day and day of week columns in water source related crime in order to plot these, just like we did for visits. So what we did, we are going to do that for. So we will have hour of day and day of week. So let's go there. In the water source related crime, water source related crime. Good. So we come here, select this, but before that we have to enter into Power Query. So yeah, great. So we move to this one and then select time of incident, and then we move to add column. Make sure that you select add column at the top, and then we look for name of day. Did they ask for name of day? Yeah, that one is hour of day, not name of day. Hour of day and day of the week. And day of the week is the same as name of day. So you can write day of the week. Day of the week. Right. Then hour of day, we select the same thing. We move to add column, then select hour, then hour of day. So hour of day. So we are done. So we come to home, then we click on close to apply. Now that we are done, let's move to our visuals. So they said crime type and then what? Plot the number of crimes for the time of D. So number of crimes. So crime we count. Let's see if we can use this. We count number of crimes. So counting will come here. Count number of crimes for hour of day. Right. Plot the number of crimes for the time of day. And so this is for the time of day. The number of crimes affecting males and females, or the gender. So I'll add the gender to the legend. Let's see if that is what they also got here. By hour of day. Okay, so by hour of day, since it is time, we are using this one. Oh, sorry, let me delete that. Select and select this. Good. So this one works. Great. And now you see that this one matches with that. So we will change the title and everything to suit that accordingly. So let's move to the next one. They said we should also create another visual that shows the number of crimes per day of the week. So this one is for time of day, so per day for the week, so that we will look at the patterns. So the same thing, so crime type, so we selected this crime type, we count, then the day of the week, and then we look at the gender. So the crime type will be counted, so I'll bring that one here, and then the day of the week will be this, and then gender will be the legend. Good. So I think that one looks like this. So I'll put it here. When I collapse this, you see it. Right. So I think that one looks like what they have here. Yes, this one. So change things to look similar. So it's left with the last one. Analyze the number of crimes per province. Which provinces have high crime rate and which provinces have low crime, specifically focusing on women. So we should analyze the number of crimes per province. So per province, we are going to use this so that the provinces will be listed down. So so province, we take it from location. Location. So that will come down. And then crimes will count. And then the gender will be the legend. Right. So this is how it's going to be like. So we'll have the provinces, the gender, and then the number of crimes. So I think this one is above 20k. Yeah, above 20k. If I check this one too, it's above 20k. So I think so far so good. We have been able to follow through, and that is what they also got. So this is what they are asking you to also do with what you have done. As it says, see if you can spot these trends I found. As water collectors, women are twice as likely. So you check um, your graph. I'm going fast because the time. I don't want the video to be so long. So it says, as water collectors, women are twice as likely to be victim of crime than men. So when you look at your graph, do you see something like that? Females are subjected to crimes, or they are victims of crimes twice as men. So looking at that, looking at this one, gender disparities, you see that the females here, 49%. Then look at the males, so 25. So it is almost like twice that of men. Women are most likely to be victims of harassment, followed by sexual harassment. So when you look at your graph, this is harassment and then sexual harassment. So look at the females, that is the dark blue, and that is the longest. Apart from this, which one is the biggest among the dark blue? This one. So that is the sexual harassment. So they said harassment followed by sexual harassment, and you can see it. Crime spikes over weekends, and almost twice as many crimes are committed early in the mornings or at night, with women again facing the same greatest threat. So crime spikes are on weekends. So when you look at this, weekends are on Fridays and Saturdays. So looking at this, Fridays and Saturdays, no, not Fridays, Saturdays and Sundays. So Sundays are like this, Saturdays and Fridays, yeah. So you see that they are looking at this. It is different from during the weekdays, and then also early in the mornings. That is here. Early in the mornings they are high. Then late at night, that is after 8 p.m. So you see that 8 p.m. It goes up, but when you come to the middle, it is coming down, or it is not as high as here the extremes, that is the mornings and the nights. Then in Amanzi, women face significantly less risk of being crime victims. Can you think why this is the case in Amanzi? So in Amanzi, women face significantly less risk. So in Amanzi, let's check. In Amanzi, yeah. So you see that the females are having less of that than Hawassa, Akachi, and Komani, and they're asking why. And I think in Amanzi they have more water taps, tapping home or tapping broken or something. I think that is why I was, unless you check, I check again. So from there, I think the rest are not something that I should go over it. But I think that is all basically. I've tried my best to explain this, although it's a little bit challenging, but I've tried my best to explain for you to also follow through and then get the visuals. At least it can help you when they ask you questions in the MCQs. Thank you very much.